Heading: Data flow models. First point. A data flow model shows how data moves through a system. Second point. It describes the input, processing, storage, and output of data. Third point. Data flow diagrams, DFDs, are used to represent data flow models. Heading: Types of data flow diagram, DFD. Side heading: 1. Logical DFD. First point. Shows what the system does without considering implementation details. Second point. Focuses on business processes and data movement. Third point. Used during requirement analysis. Side heading 2. Physical DFD. First point. Shows how the system is implemented. Second point. Includes hardware, software, files, and people involved. Third point. Used during system design. Heading: DFD components. Side heading: 1. Entity, external entity. First point. An entity is a source or destination of data outside the system. Second point. It provides input to the system or receives output from it. Draw a diagram. Side heading: 2. Process. First point. A process transforms input data into output data. Second point. It represents an activity performed by the system. Draw diagram. Side heading: 3. Data store. First point. A data store is a repository where data is stored. Second point. It may represent files, databases, or records. Draw diagram. Side heading: 4. Data flow. First point. Data flow represents the movement of data between entities, processes, and data stores. Second point. It is shown using arrows in a DFD. Draw a diagram. Heading: Levels of DFD. Side heading: 1. Level 0 DFD. Context diagram. First point. Represents the entire system as a single process. Second point. Shows interactions between the system and external entities. Side heading 2. Level 1 DFD. First point. Breaks the main process into major subprocesses. Second point. Shows internal data flow between processes. Side heading 3. Level 2 DFD. First point. Further decomposes level 1 processes into detailed subprocesses. Second point. Provides a more detailed view of system operations. Heading: Advantages of data flow models. First point. Easy to understand and visualize. Second point. Improves communication between users and developers. Third point. Helps identify missing data and processes. Fourth point. Useful for system analysis and design. Fifth point. Provides a clear picture of data movement. Heading: Disadvantages of data flow models. First point. does not show timing or sequence of operations. Second point, becomes complex for large systems. Third point, does not represent control flow effectively. Fourth point, requires multiple levels for detailed systems. Heading, State Machine Model. Side heading, definition of state machine model. First point, a state machine model represents the different states of a system and the transitions between those states. Second point, it shows how the system responds to events over time. Third point, it is useful for modeling dynamic system behavior. Draw a diagram. Heading, advantages of state machine model. First point, clearly shows system behavior and state changes. Second point, helps understand event-driven systems. Third point, useful for real-time and embedded systems. Fourth point, helps identify missing or invalid states. Heading, disadvantages of state machine model. First point, can become complex for large systems. Second point, difficult to manage when there are many states and transitions. Third point, focuses only on behavior, not data flow. Fourth point, time-consuming to create and maintain.